Alright, so we have another convention for vectors that are pointing either towards you from the screen that you're looking at or away from you, right? So because vectors have a tail and a head, that arrow or that head could be pointing into your face or away from your face. So we have a convention for that as well. So vectors out of the plane or towards you from the screen or towards you from the paper or screen, you can write either, are represented as counterclockwise curves, right? So I drew a counterclockwise curve. The counterclockwiseness is captured by where I put the arrowhead, right? So conversely, vectors pointing into the page, vectors pointing into the plane are just clockwise, right? So you have a clockwise turn captured by the arrowhead, the position where it's placed, right? It was to the left in the previous case, which captured counterclockwise turn, but this one is a clockwise turn, right? So you can write clockwise underneath it, if just to remind yourself, right? So that's the two ways of representing vectors that are pointing into or out of the plane, right? So we have that now. Okay, so with this we are done with like vector representations. You will see planar vectors or three-dimensional vectors, and if, there are vectors pointing out of the plane and this and that. So this is what you need to know. I should add that this clockwise and anti-clockwise rotation representations of vectors are based on something called the right-hand rule. We will go over that over the coming weeks and in this lecture as well. Right-hand rule. Okay, that governs how a vector will be pointing in a certain direction or not. Alright, now we come to the topic of vector algebra. Right, so close this and we will write vector algebra. So you have, you're all familiar with the concept of scalars at this point. They're just numbers which we operate upon. So it's like you take the number 2 and you add 3 to it, you get 5. And you can do something similar with vectors, except that now you have to not only account for magnitude changes, which is what a scalar actually captures as the magnitude, but you also have to find a way to account for directions. So vector algebra becomes very useful when you look at things like multiplication, division, addition, whatnot. Well, I shouldn't say division, but there's vector algebra that lets you do a lot of things. Yeah. So let's start at vector addition, right? Addition. Addition. So there are two methods that are commonly used for adding vectors. So let's say you have a vector A and a vector B. Addition of two vectors is represented by what you've seen with scalars. You just use the plus sign between them. The two methods are and you're probably familiar with these again, but we'll go over it nonetheless. Triangle law, and the other one is parallelogram law. Rule or law, right? Okay.